Hey students, it's Mr. Choate. I'm actually recording this at my house this evening. This is Thursday night. I'm recording this for some of you who are in my later classes because I'm not going to be there tomorrow afternoon. I wanted to give you the ability to watch the lesson on your Chromebook and to get the notes and stay update with me not being there. So we're going to start inverse trigonometry today. Inverse trig, I actually feel like is much easier than regular trig. Some of you are going to love it. Notice that many of you yesterday did fantastic on your tests, so good job. Many of you made great passing scores. So again, good job. I'm proud of you. I think you're going to do fantastic with inverse trig as well. So I want to make a couple of notes before we dive into the new notes. So if you haven't already, make sure you have a notebook out and that you take these notes down. I'm going to look for them in your notebooks when I return on Monday. Let's title this Inverse Trig. Of course, y'all know my handwriting is notorious. And regular trig is what we just learned. Regular trigonometry. I'm going to zoom in here. Regular trig is used, a little note here, used to find side lengths. Okay, so everything we just learned is used to find the length of a side of a triangle. And we recall those, remember the three trig functions are sine of an angle, x represents the angle, is equal to the opposite over the hypotenuse. And of course, cosine of an angle is equal to the adjacent over the hypotenuse. And the tangent, we don't do that. We do the tangent of an angle is equal to the ratio of the opposite over the adjacent. Those are our trig ratios. And often we would have an angle and we'd have one of those sides and then we would find the missing side. We'd use algebra to find the missing side. Well, inverse trig you may be guessing, is used to find angles. Used to find angles. And the three trig functions we're going to use that is actually the same three trig functions with the same ratios, except we're going to use a new button, or actually we're going to add a button to our calculator that how we use it, and then set it up just slightly different. So what that's going to look like here is the sine, or how we would say this, the inverse of sine. Notice that I have written a -1 in the exponent position there. So it's sine -1 times the ratio of the opposite over the hypotenuse equals whatever the angle we're looking for is. That would work for cosine to the power of -1, or -1 in the exponent position. The same ratio, adjacent over hypotenuse, is equal to the angle. Or tangent, inverse of tangent there, is opposite over adjacent is equal to the angle. So those, how we would say that, is the inverse of sine times the opposite side over the hypotenuse will give us a missing angle. The inverse of cosine times the adjacent over hypotenuse will give us an angle. And again, the inverse of tangent times the opposite over the adjacent will give us the missing angle. So let's see what that actually looks like. I'm going to draw a triangle. Take a moment. You may pause the video and draw this as well with me. I'm going to call this example number 1. And here is my right angle. Here is 15, 24. And we're going to put an X here because that's the angle we want to find. And I should apologize. That's fine. We can go with this. We'll go with this. So we have our triangle. This is what your problems most likely will look like. We have our triangles here. We have two sides and we have an angle where there's an x, and that's the angle measurement that they want us to find. So I'm going to set it up just like I had with regular trig. This is the angle I need to build my triangle off of. Opposite the right angle is my hypotenuse. Next to my angle is my adjacent, and across the triangle is my opposite. And I'm going to ask myself, with what they gave me, what two sides of the triangle did they give me? Well, they gave me the opposite and they gave me the adjacent. And we ask ourselves, what trig function uses opposite and adjacent? And we know it's tangent. Tangent sets up the ratio of the opposite over the adjacent, but we're not looking for the side length, we're looking for the angle. So what we're going to say is the inverse of tangent times that ratio of the opposite side over the adjacent side will equal whatever that angle is. So I have my calculator set up over here on the screen. I'm going to go to mode. Let's see if this will work here. Mode. And then I'm going to go down to radian, select degree, push enter, and then clear. This works just like on your calculator. And then I'm going to type. But notice that I'm not looking for the regular tangent. I'm looking for the inverse tangent. And how we get that is to push the second and then go to tan. And you may notice, I don't know that I can zoom in. Oh, it's going to mess it up. So if you push second and then tan, it gives you the inverse symbol. It does it for you. So second, tan, and then I'm going to type in that ratio, 15 divided by 24, close that parentheses, and then look, there's my angle. It gives me x, oh, get back to the pen, x equals 32.00538, and it goes on. We're just going to round it one place past the decimal. So my answer here is that angle is 32.0 degrees. That would be my answer. I think this is much easier than regular trig. So let's do another one together. Let's draw. Sorry. I was looking at these notes and I wanted to make sure I got them right. So I have another right triangle. This time we're going to say 24 over 16 here. We're not going to worry about the other side. And here we're going to say we're going to say x. Okay, there's my angle I'm looking for. Again, first identify the angle right here. Label our triangle. This time we have the hypotenuse. Over here we have the adjacent, of course our opposite. We go, what did they give me? They gave me the hypotenuse and they gave me the adjacent. What trig function uses hypotenuse and adjacent? Well, we know it's the cosine. So I'm going to write the inverse of cosine times the ratio of the adjacent over the hypotenuse is equal to the missing angle. There's no switching around. I'm just typing that straight into the calculator. Second cosine, that gives me the inverse of cosine, 16 divided by 24, close parentheses, and there's my angle, my answer here. X equals 48.189, and continues. And if I round that one place past the decimal, that's going to give me 48.2. There's my answer. And it's really degrees. 48.2 degrees. Okay. Let's do one more. And then I'm going to go to your worksheet and do one from your worksheet. Example number 3. Let's say they don't give you anything. Let's say they don't give you a triangle, and instead all they give you is this sine of A equals, and then they give you a number. Doesn't matter what that number is. This is all they give you. Sine times A equals 0.45. What that is saying is the sine ratio times A, angle, whatever the angle is, will equal 0.45. Watch how easy this is. We're just going to change it from regular, that's regular trig. We're going to change it to inverse trig, put that number here, and then put A here. We're gonna switch the variable and the trig we're using. So we're going from basic or regular trig to inverse, and then move that number. Does that make sense? And then you type that in the calculator. Second sine 0.45, close parentheses, and that's the degree measurement. Angle A equals 26.7 if you're rounding. It's pretty easy. Okay, let's go and look at your actual worksheet today. First set of problems says match the trigonometric expression with the correct ratio. And then please pay attention. Some ratios may be used more than once, and some may not be used at all. So don't go scratching through, because you're going to need to potentially see those again. Let's look at this triangle. I'll do the first one with you. The first one says off of A, sine of A. Here's my angle, sine of A. We know that this would be our hypotenuse then. This would be our adjacent, and then across would be our opposite. And none of these in this first set are even using inverse trig. So we're just going to set up the actual ratio. Sine, so what you'll see Mr. Choate do often is on my paper, I will write S equals O over H, C equals A over H, and T equals O over A. So then I can just refer back to my worksheet or my trig functions up there. So sine of A is our opposite over our hypotenuse, 8 over 17. Do I see 8 over 17? Wham, bam, it's right there. So I'm gonna put A here. Okay, that's essentially what you can do for the rest of those. Let's go down to what would be number 2. Use a calculator to approximate the measure of angle A to the nearest tenth of a degree. What trig do we use to find angles? There's only 2 trigs, regular trig, inverse trig. Our notes just told us that one of those trigs is used to find side lengths, the other trig is used to find angles. So since we're looking for angles here, we're going to use inverse trig. And it's to find the measure of angle A. The directions tell us which angle we're looking for. So I'm going to put a dot next to A, my hypotenuse, my adjacent, my opposite. What function uses the 2 sides they gave me? Adjacent and opposite. Tangent does. So I'm going to say the inverse of tangent times the ratio of the opposite over the adjacent will give me the missing angle. Sometimes we put X. I know that we're looking for angle A, so I'm going to leave it as angle A. And then I come to my calculator. Second, tan, 30 divided by 20, close parentheses, and there's that angle. X equals, I'm rounding it one place, 56.3. Done. That's easy. You're going to keep doing that through all the way through 10. And then down here, let angle A be an acute angle in a right triangle. Approximate the measure of angle A to the nearest tenth. So all of these are looking for an angle labeled A. And remember what we did. We took the regular trig, we made it inverse. So inverse of sine. And then we switched the variable and the number. So This may be the one we did in our notes. I think it is. Second, sine, inverse of sine, 0.45. And there's our angle. Angle A equals 26.7. That's my answer. Easy peasy. Finish this worksheet. It is due Monday. 6th period. It's due at the end of class.